A person asked me, how can I plan for stuff randomly blowing up, man? And I'll tell you what, I thought that I was going to do the teaching, but that really made me step back and take a look at the skill levels of the people that are involved in maintenance. We've got engineers on one hand that have worked hard to get their degrees. And then we've got the tip of the spear, the actual boots on the ground maintenance personnel who are tackling very complex equipment problems on a daily. So that balancing act in order to teach and bring everybody together on one page is critical for the success of our production environment. We definitely need a team concept, but if there's a divide in skill set, then we have to begin with the fundamentals for our maintenance personnel. And in this video, I'd like to discuss a solution for my friend that asked the question, how can we plan for stuff that randomly is blowing up? You know, I understand the stress of that statement from years of being involved in industrial maintenance. We initially, back in the day, were just running machines until failure. And then we call ourselves fixing it or putting a Band-Aid on it, but it was just basically just fighting fires. So now with modern manufacturing techniques, we have the ability to not only just monitor equipment, but to test equipment and to do analysis on things in real running time to where we can track data. And so that's where maintenance, industrial maintenance is really already there at real-time monitoring and looking at trends and keeping a close tab on the process controls to be able to predict and plan for these type of failures on the day-to-day work floor. I'd like to discuss motor testing and motor controls that we have to analyze motor data, because that's a big point that we have to deal with. Every manufacturing process has electric motors, usually three-phase motors, continuous duty, and we have the ability to predict failures on these types of motors due to technology. As fundamental as using a clamp-on amp meter and checking each phase for balance. If your current is load is higher, you know, you'll start to see that in your meter readings by checking each phase. And if something's out of balance, you know that that motor is struggling or having problems, whether it be one phase, two phases, or all three phases. If that motor's running higher current than the nameplate on the motor is suggesting that in the range it should be in, we may have a problem sizing a motor that's not sized properly, or the load's been increased. There's all sort of factors that can come into play, but there are current transducers that are mounted inside the machine that are already clamped around each phase of a motor to be able to not even open a panel or a pecker head on a motor and be able to monitor in real time. Just walking past the panel, you've got all three phases showing what current readings in real time. And we can also send a signal to your PLC controlling that process. a 4 to 20 signal or 0 to 10 volt DC signal to an analog card on a PLC. A PLC is a programmable logic controller that controls most of your processes, your speeds, and it monitors, it tracks data. It's pretty much the heartbeat of your process. So let's work together. We're Wilson's Industrial Consulting, and we'd like to partner with you to help train, discuss, just talk about your process. There are many ways of improving process controls and your process capabilities. So let's work together. I'm going to leave a link in the description of this video.